So this is Unit 2, Section 1. It's on average and instantaneous rates of change. Guess what? It's an introduction to a derivative. What are the main topics in calculus? Remember you did that nice little thing that you wrote for me back in the beginning, a little paper on what is calculus, and there were 3 big topics. Integrals was one of them. Derivatives was another one. And limits, right. So we got through limits. We're kind of now going to take what we know about limits and we're going to turn it into talking about derivatives. So this is the first section. It's an introduction to derivatives. Throughout this unit, they're going to be showing us different ways to find derivatives. And I'm going to ask for forgiveness now because the way that you're going to find a derivative for the next few sections is pretty tedious. And then I'm going to show you a shortcut trick. And you can find derivatives just off the top of your head. So we are going to start with, because the whole idea, and they do this on the AP exam as well, they want you to know where this derivative is coming from. What are they really talking about? And it really is all based on limits. So they're linking you from limits to derivatives. And that's what these longer problems that we're into for these next couple sections anyway are going to be talking about. So intro to derivatives, instantaneous rates of change are derivatives. So it all is about the slope. Do you remember I was going to show you slope dude? Do we need to see him again? No, I think we can survive. You got him, right? You saw that before. So it's all about the slope. It's the slope of a tangent line. It's a rate of change. So back to the day of slopes, y2 minus y1 over x2 minus x1. Sometimes it's the change in y over the change in x. That's that triangle thing. Or it can be the difference between the dependent variables versus the independent variables in the bottom. And if you recall the picnic table, remember the picnic table with the martini glasses on top, right? That's how we remember how these x's and y's go. So that was my margin note, was about the picnic table. All right, so here's calculus. Here's what they're going to say to us in calculus. The average rate of change on the interval from A to B is represented by f of b minus f of a over b minus a. Well, that's slope, just put in a different way. And these were from the video, if you got a chance to watch it. The average rate of change from a function, if the function is the natural log of 3x over the interval from 1 to 4, you're going to take f of 4 minus f of 1 over 4 minus 1. And so you go to your handy dandy calculator and you put in the ln of 12, 3 times 4, minus the ln of 3. That's what I'm just looking at the same thing. Yeah, you're catching me too. I don't know whether I didn't write it right from the video. Maybe he got it wrong on the video. I
always forget that your pens are erasable.
Oh, I know.
So nice.
They're my favorite thing ever, my erasable pens. Yeah, f of 12 minus f of 3, that makes more sense, equals 0.462 when you divide by 3.
Wait, I thought it is, wait.
3 times 4 is 12.
Yeah,
3 times 1 is 3.
yes. But it's ln of 12 minus ln of 3, right?
Correct, yes. I had it originally written as an ln of 1.
When I try to put that in my calculator, it just says ln of 12.
Yeah.
Okay, and that's true. So this calculator tends to keep things exact. So let me pull out mine and I'll show you a couple of options for that. All right, so on the calculator, the question is, the calculator is just showing the ln of 12. So I do the blue button and the x gives me ln. I put in a 12. And it says, yep, ln of 12. And you're like, yeah, that's what I just typed in there, right?
Yeah.
Minus the ln of 3. And it gives me this 2 ln of 2, is what my calculator is spitting out at me. Now, if I don't like that form of the answer, if I want it as a decimal, hit the Gatorade button. You can debate whether that is yellow or green. And press enter. Now, somehow it double subtracted that ln of 3, which I didn't want. So let me go here. 2 ln of 2. The other thing you can do is just put a decimal point with one of those. If you just put a decimal point in there somewhere, it's going to give you the decimal answer.
Wait, so if I just put like ln of 3 decimal? then it'll.
Yes, ln of 3 decimal. Yeah, it'll
Or
give
the
you that.
Gatorade button.
Yep, or the Gatorade, yep. Usually the Gatorade button. You got to watch the Gatorade button, though, because it just did it to me on this one, where it did the extra subtraction of that thing I was trying to do,
Okay.
rather than just giving me the answer I wanted. Now, it gives me this 1.386. Well, that's got to then be divided by 3.
I
just gives me the decimal right away.
Some of them, it depends on what your mode is. It might just give you the decimal right away. Yeah.
was supposed to do that, but this looks like it.
Okay, so there's a couple options to get around that crazy decimal issue in your calculator. All right, how about if I give you from a table? They say, okay, now here's a table. Figure out the average rate of change for the interval from 2 to 30.
We were gone for a while. We do 3 decimals, right?
Yes, we do 3 decimals. And he went into this whole tirade about truncated, yada, yada.
Yeah.
Just rounded to 3 decimals. Come on now. He was like 1,000th away on the other ones. I'm over it. Like, just round it.
Like talking from that.
He was really going off, and I was like, dude, just round it to 3 decimal places. Okay, so now we're from a chart. Now, you know the chart, they can get you. They're not necessarily using the whole chart. You're only using what they tell you to use. You're only going from 2 to 30. So you're forgetting this whole first set there. So 2 to 30. So you're going to take f of 30 minus f of 2, and they go on top. So 7 minus a negative 2, and 30 minus 2 is on the bottom. So you end up with 9 over 28. All right, it's 9 over 28. That doesn't simplify. There you go. So average rates of change are fancy pants words for find me the slope. You know how to do that. You've known how to do that for years. All right, so then he was trying to get you now to think about, how about if I am...
Can you move your computer down?
Yep, are you ready for the next part? So, what does it look like if I'm an average rate of change? These quotients represent an average rate of change for a function over an interval. You can use this. He's growing you towards this next definition of a derivative in a minute here. F of a plus h minus f of a over a plus h minus a. Or the same slope formula we just were using, f of x minus f of a over x minus a. It's also the slope of the secant line. There's a couple blanks in there that he has. The slope of the secant line. If you remember secant versus a tangent, you may or may not. Secant versus a tangent. A secant line crosses through the curve in 2 places, in more than one place. Secant line, that's this guy here. This would be a picture of my secant.
There's a lot of different secants.
Correct, there's a lot of different secants that you can use. Correct. And what they're really doing, when you get into derivatives, derivative is the slope of the tangent line. Now, tangent lines are different because how many times can they cross through the graph? One time, right? Once and only once. So the question then comes about, and I'm going to erase this just to give you an idea though, can I figure out a tangent line that would have the same slope as that secant line that would go through this curve? Check that guy out. He would be parallel, right? So he would have the same slope. That's the slope of the tangent line. This guy would be tangent. He crosses through in one place. And you can see how that secant line could be your friend if you're looking for a tangent line, because you would have the same exact slope. All right, that's kind of where this is going. But what the heck is this H thing? What is H? H is when you get really, really close to, in this case it was at 0 or whatever the picture was that he was doing. Remember when we do, when we were doing some of those limit problems and we went, like we were at 3 and we went to 2.999? That H value would be that 1,000th that you're away from 3. If you're at 2.999 and you're trying to hit 3, you're 1,000th away. That 1,000th value, which is really close to 0, is your H value. So these H things that are coming up are values that are really close to 0 but not quite 0, along the lines of when we did those limits. Does that make sense? Mm-hmm. Okay. So if I'm figuring out the slope of a plus h, that's like figuring out 3 plus 0.001. Like you're 3.001 away, rather than just using 3. And why that's going to be important to us is because a lot of times if I do a direct substitution of 3 itself, I'll get a 0 denominator and it won't work. We saw that with the limit problems we did. Alright, so that's the average rate of change. H is a value that's just really close to 0.
Okay, so A would be, A plus H would be 3.001. It wouldn't be 3 plus 3.001.
Right, it would be 3. The H value is the value that's close to 0. So the H value would be the 0.001 part. Yeah. Alright, so then you get into the instantaneous rate of change. I do have a margin note saying that it's the slope of a tangent line at an exact point. I just drew you the idea of that tangent line on the picture from up above. Tangent lines only cross in one place. So the instantaneous rate of change is like the slope of a tangent line at an exact point. And the difference is that now we're taking the limit. So it's not just the slope formula anymore like it was from up above. It's now taking the limit of that slope, or the limit of the average rate of change slope that we have as well. This is also the slope of the tangent line. I think that takes us to almost the end of the notes. When you flip the page, here is this first guy that he did, the example that he did. And I don't know if you remember this from back in pre-calc, from back in the million years ago. We did this stuff. These were called difference quotients. And we did them in 3 parts. When I taught them to you, I taught them to you in, you have 3 steps to this thing. Step number 1 is to figure out what f of negative 1 plus h is. Step number 2 is to figure out what f of negative 1 is. And step number 3 is to put it all together and divide by h. Does that ring a bell?
A lot easier than what you said.
Yeah, okay.
So,
Did
can you say step 1 again?
Yeah, here's my next question. He literally did these examples on there. Do you want me to do these out by hand with you?
Yeah.
Yes. Okay, so even people that watch the video, they'd prefer me to do these by hand. That's absolutely fine. Let me find my blank of it, and I'll show you what I'm talking about. Okay, so here's the question. You have a function, x minus x squared. They give you an exact point value, x equals negative 1, and they want you to find the instantaneous rate of change. They reminded you of the formula, so that's what you've got going on here. So the first thing you're going to do is set it up. The a value is your, what they tell you the coordinate is. So negative 1 is your a value. That's your x value. Sometimes they call it a, whatever. But that's what's going in. So I'm replacing, the first thing I've got is the limit, and you need to write small with these things because it's a lot of writing. All right, so the limit as h approaches 0. I can't change any of that. It's going to be f of, my a is negative 1 plus h minus, now I'm here at the subtraction sign, f of a, well a is negative 1, f of negative 1, and all of that is over h. So step 1 is plug in the x value they give you, and let's see where it takes us. Now the next thing is, now you have to figure out, and here's where the steps come in that I was talking about from back in pre-calc. The first thing that we did was we figured out this part. What's f of negative 1 plus h? And then we figured out what f of negative 1 was. And then the third thing was we put it all together. We divided by the h. Those were our 3 steps when I taught this to you back in the day. All right, so let's figure out what is f of negative 1 plus h. This is our step 1. So I go to the function. Now I haven't even looked at the function up to this point, so now I'm going to look at the function. The function is x minus x squared. Well, you're replacing whatever inside your parentheses for the x's. So I have, instead of it being an x, it's going to be a negative 1 plus h minus x squared, negative 1 plus h squared. Like composite functions from back a ways ago.
So it's the whole thing squared, not just the h squared.
Yeah, you got to literally FOIL that bad boy out. That second one. Yep. The first one, there's nothing to do to it. You're just like, all right, cool. You're negative 1 plus h. And you also have to be careful because of the subtraction sign that's here, because that's going to change all the signs after that. I would not go there yet. I would totally just do the squaring first, one thing at a time. Don't try to do too much because your brain will be boggled. Okay? So I have a minus sign parenthesis, and I'm going to literally FOIL out a negative 1 plus h. So that's negative 1 times negative 1 is 1. I'll have two h's in the middle, but they'll be negative. And then I have an h times an h, so I have plus an h squared. Now I'm going to combine like terms. Actually, I should distribute the negative first, right? So it'll be a negative 1 plus 2h minus h squared. And so in the end, this guy comes out to be a negative h squared. Nobody combines with him. I have a positive 2h and a positive h, so I've got a positive 3h. And I have a negative 1 and another negative 1. They give me a minus 2. Now all of that was just step 1. Right? All right, let's go to step 2. Step 2 is like, what's f of negative 1? Well, if I put a negative 1 into my equation, that is a negative 1 minus a negative 1 squared. I square first, get a positive 1. I apply the subtraction sign, gives me a negative 1. Negative 1 minus 1 gives me a negative 2. And then step 3 is put it all together. Okay, so here's where I'm at with step 3. I take the limit, bring it back to the problem it was, as h approaches 0, of f of negative 1 plus h. We said that's negative h squared plus 3h minus 2 minus f of a, f of negative 1, which is a negative 2. Parentheses are your friend in these things. You got to watch. There's a lot of double negatives and such that come along. And all of that is being divided by h. All right, so thing number 1 that I see, do you see anything canceling? Yeah, you got your 2's going, right? So you got a negative 2, this will be a plus 2, so I can cancel those out. They're off the market. And then I have, if I simplify this down, I have an h that can cancel. Here's where I'm at. I'll just show you the step here. H is greater than 0, or h approaches 0, of negative h squared plus 3h all over h. What can you tell me about all that? The h on the bottom cancels, right, with one of each of the h's up top. So now I have the limit, see if I can fit it in here, as h approaches 0. If I take an h away from the top, now I have a negative h. If I take an h away from the 3h, I have plus 3. The h on the bottom canceled, so here's where I'm at now. Now it's direct substitution. You let the h be 0. So if the h is 0, then I've got 0 plus 3, and my final answer is 3. That, my friends, is your instantaneous rate of change at x equals negative 1.
Miss Wenner,
Yes.
why did you take the h away from the 3h too?
Because this h is a denominator, and there's 2 pieces in the numerator, and the only way I can divide that h is if the h is divisible in all 3 locations. So it's, I'll come over here. So here's where I was at. I was negative h squared plus 3h all over h. And it's the same thing as me saying negative h squared over h plus 3h over h. And then if I divide out the h, it's a negative h here, and these h's would cancel, so there's my plus 3. Does that make sense, my love? Yeah, she did. Okay, got it. All right, I'm going to erase that so I can talk about the other question.
You, that's so confusing.
I thought so too, Grace.
Am I
Like,
writing everything out or what? It made it so confusing.
and you know what? These are ginormous problems. They're really long. Like, if he lost you here, there was no hope for you when you came down to
I
the
didn't
bottom.
understand how he drew. He
Going
just kept
on.
like, he was just saying, all right, plug this in for this, and then I'm gonna solve it. And fast forward it while I solve it.
Yeah, right. He did one of those fast forward things he does. Yeah, I thought so too. I thought he was very confusing, and I knew how I had taught this to you guys back in the day. Does this ring a bell? No. Like, there's yeses and nos in the house. You might have forgotten them because they're ugly. Like, they're not ones we liked back then. It was it just last year? Yeah. Yeah, these are not ones that are normally very, like, lovable. All right. Does it make sense, though, that if you break it down into those 3 parts and then put it back together?
Makes more sense.
Yeah.
Cool. All right. We're going to try some more, obviously. So now here's the next one. Now this one they don't give you this one's a little bit nicer. This one they don't give you. You notice the difference. This one's a limit with your a plus h stuff. This one is the limit just as x approaches a for the function minus f of a over x minus a. Kind of similar, but kind of not. Here's what this one's going to look like. You're taking the limit as x approaches negative 1. That's your a value. For your function f of x minus f of negative 1 all over x minus negative 1. Do you see the difference in that one? The setups are just watching. Just
So-
digest that for a second.
I'm sorry. I can't
No.
really say. What is the first number
It-
after f?
It's the limit as x approaches negative 1, because that's the number they're telling me. F of x minus f of negative 1 over x minus negative 1. So you see how your denominator here, x minus a, is different than your denominator over here, which is just an h.
How do you know it's x approaches negative 1 if it's x approaches a?
A is your x value, just
Okay.
like it was over here in the first one that we did.
Yeah, I think that's what was confusing me most last
Oh, I
night,
see it.
was
Do you see
the
it?
variables.
Yeah, and why would you call it a? Why is it a and not x? Like, why are you? Yes, exactly right.
I don't get it.
Yes.
Like, why couldn't they give us at the top instead of saying x equals negative 1? Giving us
Or why could they say a equals negative 1, right? That would, that's really what they're saying, but they're just not saying it quite
This
that
side
way.
I thought was easier though.
Yeah.
Yeah, this one is easier, for sure. You don't have quite as much stuff going on. All right, so let's put it together. Let's see what we got going on. The limit as x approaches negative 1, my function is x minus x squared, f of x, minus f of negative 1. Well, f of negative 1, you figured out over back here in this last problem that that's a negative 2. And that whole thing is over x plus 1. I'm going to stop there for a minute because I just filled everything in and let you make sure that we set that right. Does that make sense? F of x minus f of negative 1 over x minus a negative 1. Okay. So that means that my next step, when I put this all together at this point, I'm at x approaches negative 1. I have an, let me put it in order. Negative x squared plus x plus 2 over x plus 1. Well, let's try direct substitution, right? That's our favorite friend for finding a limit. And I see the shakes of the heads in the room here. That ain't going to work. Because if I plug in a negative 1, I end up getting a 0 denominator. So maybe there's something else I can do. Can you think about your limits, things you know about limits? Factoring, possibly, right? It looks like maybe, but I've got this stupid negative out in front. So let's think about that for a minute here. If I factor out a negative 1, that's going to give me x squared minus x minus 2. All right, does that work? Oh, sweet! Negative 1 gives me an x minus 2 and an x plus 1. Now that makes me quite happy because now my x plus 1's can cancel. And now maybe, just maybe, I can do direct substitution. I get a negative 1 I'm left with and an x minus 2. I'm still writing that I'm taking the limit because I haven't taken the limit yet. But now I'm gonna. If I put a negative 1 that's in front, and negative 1 minus 2 is a negative 3, and I multiply them together, lo and behold, I get my same answer using either method. I get my number 3 there. All right. Then the next two that he did, these could have been confusing as well. I'm not sure if when you were watching the video. Identify the function we were working with. Then identify the x value for the instantaneous rate of change or the slope of the tangent line at a point. So you know there's two formulas. The one formula is the limit as h approaches 0. The other one is the limit as x approaches a. There's two different formulas. So the first thing you're going to identify is which one are you looking at. So I'm looking at this number 1. It's the first guy. It's the h approaches 0. All right, so think about that setup, that fraction. And he even has it at the top of the page here. Let's see if I can pull it down. I'm looking for this guy. So if I'm looking at all this setup, what they're doing is they're giving you this part. And they're saying, what was the function? You have to figure out the function and the point. Where this one, they gave you the function and the point and you had to evaluate. So you see you're going backwards. So job number 1 is, are they using the limit as h approaches 0 guy, or are they using the limit as x approaches a guy? And we can see in number 1 we're doing this. Well, where in this fraction can you tell what the function is? The second part. Right, exactly right. This is like your f of x part. So all right, let's think that through. If I come down here, the second part is here. That's telling me what my function is. So my function is going to be 5 ln. Now somewhere in here has to be an x. So if I'm looking at this guy, I've got to think about what my point is. When I plug in whatever my value is for the x value, the x value makes this become a 1/2. So we're going to put on hold for a second what this fraction is. What's the rate of change number that I'm looking for?
4.
That's 4 because see, it's with the h. Anything that's with the plus h, that's telling you, that's an indicator for what the number is. So you're looking for what it is at 4. Well, when I plug a 4 into this fraction that the ln is, I get a 1/2. So if it were 4 on the bottom, my x value is a 4. The x value has to be the value on the bottom. If the x value is 4 and it reduces to 1/2, what's the numerator?
2.
There you go. That is that function. These are a little tricky. I think this one's harder than most. When you see some of the problems that we do, like examples in just a minute or two, I think they're a little bit easier. And these actually do get easier the more you see them.
This made more sense to me than
The top stuff?
Yeah.
Okay, good. Well, that's good. This can be confusing too, so
I don't know if it's the way they're not explaining it though. It's not making no sense.
yeah. I thought he scrambled through that pretty fast too.
Wait, so how do you know the instantaneous rate of x is 4?
It's not the instantaneous rate, it's at x equals 4. You don't know that the rate's 4. You just know it's at x equals 4. Yep. All right, number 2. This is the end of the examples that he did. Now you've got to decide which formula is he giving you, and this is one as x is approaching pi over 2. Well, that's this guy. That's this format. And if it's this format, you can see f of x is the beginning part. It's the f of x part, right? So go back down here. Let's see what the beginning part is. In the beginning place is the sine of x. Well, that's your function. And this one's even easier because the x value that you're looking at is whatever you're approaching right here. As x approaches pi over 2. All right, then pi over 2 is my x. Done. I like those better. Right? They seem so much easier. All right, let's try some of these examples. So I just randomly picked some of these. I picked the ones I thought would be a little more tricky, like number 3 from the practice. My kitty poos at home. Anybody have questions before we move on? All right, I'll take that for a no. Here we go. All right, h of m equals the tangent of m plus 4. That's my number 3. Going between pi over 4 and 3 pi over 4. H represents hair, m represents months. Now you'll notice in number 1, they did not give you anything that the variables represent. So for this one, it's as if you're going to put units on it. This first one, number 1, you wouldn't have units on it because it doesn't have anything that they're giving you. The answer we're going to get for number 3, we're going to have to put units on it because they gave us parameters of what those variables stand for. All right, so h of m. They want us to find the average rate of change. Well, an average rate of change is just going to be your f of b. I'll put it up here, top. F of b minus f of a over b minus a. Right? If we go back and look at the front page, that was what an average rate of change was. So for this particular problem, they're calling it h. So it's going to be an h of 3 pi over 4 minus h of pi over 4 all over 3 pi over 4 minus pi over 4. I'm just putting it into your f of b minus f of a stuff. Well, let's hope that these come out pretty for tangents, right? If I go to 3 pi over 4 on the unit circle, I'm looking on my unit circle here, it's the coordinate negative square root of 2 over 2, positive square root of 2 over 2. To find tangent, do you recollect? You've been looking at your chart? Yeah.
That's the thing, are we gonna have to not?
Yes, Mr. AP will not let you bring your chart.
Can we really relearn how to do that?
Yes.
Could we do a couple of those quizzes?
Yes, we can definitely go back. I agree with you. That's a great call.
I think I'm good. I just can't remember if sine is x or cosine is or cosine is x.
Yeah, sine is y.
Which doesn't make any sense in my head.
That's how I remember it. It's the opposite of what
For some reason.
Cosine is x. How about doing it this way with the alphabet? C comes before S, cosine, sine. Cosine is your x value. Sine is your y value.
Okay.
Alphabetically, that kind of fits.
Okay.
I don't know if that'll, I don't know.
It might help me.
Give it a shot. Anyway, tangent's y divided by x. Now in this case, if you have square root of 2 over 2 divided by a negative square root of 2 over 2, you have negative 1. Yeah, so this one is okay. So if I put a 3 pi over 4 into this, I get a negative 1. What's negative 1 plus 4? 3. So h of 3 pi over 4, I'll take you one more time, is the square root of 2 over 2 divided by a negative square root of 2 over 2, so that's a negative 1. And negative 1 plus 4 in my equation gives me 3. I'm going to do the same thing with pi over 4. Here's my subtraction sign. Pi over 4. Pi over 4, the coordinate is the square root of 2 over 2, square root of 2 over 2. When I divide them, I get a positive 1. So this becomes a 1. 1 plus 4 is 5. Now, do you need me to go through that one more time? Because you're kind of thinking about that a little bit. You okay? All right. 3 pi over 4 minus pi over 4 gives me 2 pi over 4. 2 pi over 4 is like pi over 2. We're doing a whole lot of mental math in the midst of all this because our box is only so big. So here's where I'm at now. 3 minus 5 is a negative 2. Negative 2 over pi over 2. I can't leave that as a complex fraction. So let's take this and go horizontal like we do. If I do a negative 2 divided by pi over 2, keep change flip, negative 2 times 2 over pi gives me a negative 4 over pi as a final answer. Now, because we've got a whole lot of stuff going on our picture, I did circle that answer. It is not recommended by Mr. AP to circle answers because it's better for whoever's reading your paper to not, they'll just directly go to whatever that is, and if it's a wrong answer, they won't see all the work you did to get there. What,
I circle my answer every time.
Yeah,
I've been
it's a
training
habit
myself.
to
I've been
not,
training myself.
that's why I'm bringing it up, exactly right. We are circlers because we're math people, right? We like, this is it, this is my answer.
If you're like looking at it.
Yeah, the idea is that the reader will actually have to search for your answer and will have to look at the work you've done to get there, so that, and they give partial credit. So if you get,
like arrows where my work is going.
they say just let the reader.
But sometimes I write like all over. I'm like going this way one time and then
And
going this way
yeah.
another.
I agree with you. I don't tend to keep it all consistently sometimes. All right. Anyway, try not to box your answers in. Is the
Taylor
idea.
told me that over the summer and I was just like,
Ooh,
oh.
yeah. It's definitely a habit. We all do. All right. Got the idea. That's
Do that on your answer keys.
that's why I never do
always
that.
so confused.
I try not to do that. I do try hard, but it is hard. We're math people. We like to box our. Here's my answer. Darn it.
Yeah, sometimes I get mad when you don't box. I'm like,
Which one is it? Where is that? Yeah, exactly right. That's why you got me. All right, number 4 is still the same directions. Oh wait, we forgot units. This was, what was he doing? Hairs per month. I'm gonna unbox myself here. Hairs per month.
Odd units. I've had some odd units.
Yeah, he likes to do that. He likes to like mix it up on you.
Like dollars per year, number 2 kind of makes a bit more sense.
Yes, dollars per year definitely makes a lot more sense than hairs per month. Especially with pi in it. What? Like, right? Although I guess if you're like Maddie and I with the curly hair, we've got the ringlets going on. There's circles involved. Little pi. All right, next one I saw that I thought was interesting was number 4 because it has an ln in it, and I didn't want that to scare you. The question is the same. Find the average rate of change, f of b minus f of a over b minus a. So here I go. This is going to be f of 7 minus f of 2 over 7 minus 2. If I go to my calculator, that's the ln of 7 minus the ln of 2 over 7 minus 2 is 5. Now I showed you on your calculator, if you don't like because it's going to spit out at you the ln of 7 when you put ln of 7 in, you can do ln of 7 with a decimal point, and you only have to put the decimal in one part of it, and it'll automatically give you a decimal answer. You don't have to keep putting the decimal in. You can. So take a second and tell me what that comes out to be. I want you to round to 3 decimal places.
1.252. Or 1.253.
Did you do?
I got 1.2. I mean 0.25.
That's what I got.
Yeah, final. I'm hoping for a 0.251.
So make sure you divide it by 5.
Oh, I was only doing the top set.
Okay, there you go. Yep, take it and divide by that point, the 5 there.
Yeah, now I got 0.250. 0.251.
Yeah. And again, he went in this whole explanation about truncated versus rounding just Don't round too early, that's the only thing. Be careful. And we're going to talk about that. There's a question that came up somewhere in the midst, in either the first section or second section, where I wanted to talk about rounding and things. All right, so there's number 4. We're flipping over. Next one I want to look at is number 7. And 7's one from a table, but the direction is still the same thing. Find the average rate of change. Well, average rates of change, I'll put it down in this number 8 box just because that way you can see it. Again, it's f of b minus f of a over b minus a. And we're going to apply that in number 7, going between 0 and 12. Now, they gave you different parameters each problem using the same table. Number 6 goes between 3 and 13, number 8 between 3 and 4. And you can see we're doing the one between 0 and 12. So in other words, I want to know what f of 12 minus f of 0 over 12 minus 0 is. And so you go to the chart and you say, all right, well, f of 12 is 5. F of 0 is negative 2. 12 minus 0 is 12. That makes me have a 5 plus 2. And the 12 on the bottom, nothing reduces. I'm not going to box it. There it is, 7/12. So from a table, easy peasy, lemon squeezy. Is that how that goes?
Yeah.
Okay. All right, next one. Number 11 I chose. Number 11, now you have a graph, and it's going between negative 4 and 2. And you say, okay, well, same idea. I'm taking f of negative 2 minus f of negative 4 over negative 2 minus 4, minus negative 4. And you're like, wait a minute, how am I supposed to figure this out, right? They didn't give me an equation, they didn't give me a chart, but they gave you a graph. So you're going to go to negative 2 on your graph, and you're going to read what's the corresponding y value, what's the f of b. So if we're at negative 2, you're at negative 1. Do you agree? If I'm at negative 4, negative 4 is over here. I'm at negative 1 again, but remember it's minus a negative 1. Negative 2 plus 4 on the bottom gives me a 2. And I end up with a whole lot of nothing. You get an answer of 0, right? Okay, that's your answer. So be it. Alright, then they try to get really complicated with you, and they give you 2 functions, and they say the graphs of f and g are given. For each function, find the average rate of change on the given interval. But I'm looking at 13 is the one I chose to do with you. And so the function is now called k. So I want to know what k of 0 is minus k of 4, negative 4, that is, over 0 minus negative 4. Yeah, right?
It's gonna ruin my head.
Yeah, it's going to play with your brain a little bit. So here's your story with number 13. You need to know what k of 0 is. And you need to know what k of negative 4. Let's just start with the 0. Well, k is defined by f of g of x. These are those composite things, and you've got to start with the middle. Well, our x value is 0. So in other words, for us, it's f of g of 0. Right? The x value we're looking at to find k of 0, I'm plugging that in. Well, g of 0, let's go to g. G's the bottom guy. Go to 0. I get a negative 1. Which means I want to know really what f of negative 1 is. So now I go to the f guy, and I see at negative 1, he's a 3. And so my answer for that, I just blew Grace's mind. That is one of the benefits of seeing you all like here in class. I can read and see what you're doing. Okay, so let me try again. I'm sure you're not the only one that got confused on this. So when you write it, you're writing f of g of 0. You okay with that, right?
Yeah.
Okay, now, you start with the inside. You got to figure out what g of 0 is. Go to the g graph. When x is 0, what's the y? Negative 1. So now you want to know what f of negative 1 is. So now you go to the f graph at negative 1 and you read the coordinate, and the coordinate is 3. We're going to do it again with negative 4. So k of negative 4 is f of g of negative 4. Go to g negative 4. That gives you a negative 2. What is f of negative 2? Go to negative 2, f is 3. Like, can you see where this is going? Plug it in. I get a 3, k is 0. K of negative 4 is also a 3. 3 minus 3 over 0 plus 4 gives me a 0 over 4, or 0 again.
They didn't give us more space for this.
Yes, oh, wait till you see the next part for space. Holy moly.
Yeah, they really.
They did not. In
They
fact,
don't
I
care.
think what I did, and it's true, I did. I did it all, like these are 15 through 20s. I flipped over the page. I did it on the back. There was no way I was fitting in that box. I'm not going to get in that box. We'll look at that in a
Not
minute here.
looking good.
Okay.
You have this like blank paper.
So what we're getting into next is finding instantaneous rates of change. Okay, we got the average rates of change. We did it from equations, we did it from tables, we did it from graphs. So you've seen all that stuff. Now we're looking at instantaneous rates of change. Well, that brings in now limits. So now here's what I'm looking at. We are not going to do, I'm going to do number 16. And again, the boxes for these are probably not big enough. So I flipped on my page. I'm just going to show you on the screen there. This is how I ended up doing these problems. Right? They take quite a bit of space. So just saying, if you have a blank piece of paper and you would rather do it on that, that might be an option. They were very nice to us in the directions, and they gave us what the formula is they wanted us to use right here at the end. So I'm using the formula. The limit as h approaches 0 of f of a plus h minus f of a all over h. So for these 15, 16, 17, that's the formula I want to use. All right, so here's what I'm going to do. What's my a? What is the x value in number 16 that I'm talking about? And the x value is 5. And so what this one's going to look like, now I'm going to take up this whole set of boxes here to show you. So it's going to be my limit as h approaches 0 of f of 5 plus h minus f of 5 all over h. Equals the limit as h approaches 0. If I put a 5 plus h into the equation, which is just the square root of x, that's going to be the square root of 5 plus h. If I put a 5 into the equation, it's going to be the square root of 5 all over h. So that's what it looks like when I substitute in. Can direct substitution work? If I put an h of 0 in there, is that going to get me anywhere? It's not going to take me anywhere, right? And so there has to be something else. Did we learn something with limits in the last unit?
You can do the times that adding.
I can do that times that it's the conjugate thing. Yes, you're thinking about the same thing I'm thinking about. So what we're going to do, you can't see. Can you see now? Hannah. Okay. I'm multiplying by the conjugate of this loveliness, which is going to be the square root of 5 plus h plus the square root of 5 over the same thing. The square root of 5 plus h plus the square root of 5. Well, what's that going to look like, right? So this one is going to be the limit as h approaches 0. When I FOIL out this thing, it really is just firsts and lasts because the middle term cancels. That's the whole idea of the conjugate. And so I end up with a 5 plus h, no longer a square root, And then minus the square root of 5 times the positive square root of 5 is minus 5. Now my denominator is a hot mess. My denominator is an h, and the part of my conjugate I'm left with, 5 plus h square rooted plus the square root of 5. Let's hope and pray that things cancel out, and they do. All right. I'm going to say bye-bye to my 5s. Bye-bye, 5. I'm going to say bye-bye to my h's. Whoop. And now what I'm looking at is just the limit as h approaches 0 of everything canceled. It's a 1 over the square root of 5 plus h plus the square root of 5. So that when I try direct substitution now, my h is a 0, so I get 1 over the square root of 5 plus another square root of 5. I have 2 square roots of 5 on the bottom, and that is my instantaneous rate of change. No, Mr. AP is okay with you leaving that down there.
Good.
Yeah, how about that? There aren't many things in Mr. AP you like about him, but you like that one. Do we dare have time for one more? How are we able to cancel the 5s at the top? All right, so the 5s at the top, when I foiled these two things, the first two square root pieces, they become a 5 plus h. And when I foil these last pieces, negative square root of 5 and a positive square root of 5, they become a minus 5. And so my 5, I had a positive 5 and a negative 5, and that's where those guys canceled from. And then I had the h on top and the h on the bottom. That was something. We were calculus today. We are rocking our world. I will see. I don't want to start this last one with 3 minutes left, right? Because you're going to get interrupted to wash your desks down anyway. I would say, now I have this being due tomorrow. I think I'm going to keep that as a being tomorrow, except, oh, no, I don't want to keep it tomorrow. I want it to be Wednesday, because Wednesday I want to finish these notes. There's only 4 more examples that I want to do with you from this section. So we definitely can do that on Wednesday, even though our shortened period is. I see these problems and they're pretty quick. So our task on Wednesday is to finish these notes, these examples. Then Wednesday night, this whole section will be due. Now some of these take some long time to do. So my suggestion would be, do some of the problems. That way you're not like crammed on Wednesday to try to get them all done. So I'm not assigning them, they are actually due for Wednesday after I've finished the examples from the section.
Miss Funner,
Yeah.
Can you do the beginning of 15 real quick? I just want to make sure I didn't do anything wrong.
The beginning of 15,
Because I feel like
I'm going to show you, see if I can show you on the screen here.
I feel like I'm on
Those of you that are online, you guys are good to go. You heard what we're up to. We're going to finish the notes on Wednesday. This assignment will be due for Wednesday night. All right. See ya. You guys too. Have a good day. Sid, I have it up there. I'm not sure if that helps you at all because I know you're having a hard time seeing that. But
I'm gonna go up.
yeah, come and check it out. Actually, here, just take this.
Oh yeah. Okay.
Right? I don't know that I guess they're not announcing to hose your desk down, so take a second and wipe yourselves down there. They usually announce it.
Where did you get this part? Like the 1 plus 1.
This is the first 3 terms are from
Yeah,
this.
I got that.
And then this is when I put a -1 into the function. -1 squared is 1. 1 plus 1 is 2. However, remember it's minus that.
Mm-hmm.
So it's going to be a -2, and that -2 on the end
Yeah,
is
but where'd the
represented
1 minus h in the middle come from?
from here.
Oh, wait.
It's x squared minus x.
Oh,
Right?
that's where I went
Right?
wrong.
Yep. Does that make sense?
I forgot the minus x.
There are so many places to make little mistakes in these, Sid. It's crazy.
I wish we still had a lot there in the goal.
I know.
Oh, thanks. Oh, yeah, thanks.
And Catherine, did you grab a packet for Hannah? Did you do that already, Catherine?
Yeah.
Okay.
Yeah.
Oh, see, I forgot